Dr. Lisa Briggs from Cranfield University, and today I'll tell you about my work on ancient DNA from shipwrecks, where it comes from, and why it matters. In a nutshell, we sought to understand where exactly DNA found on underwater deposition sites comes from and how it got there. So first, we set out to look at a bunch of cargo items, primarily composed of ceramics, to see if we could get genuinely ancient DNA from inside the ceramic matrix of these cargo items. Then we went on to look at seafloor sediment samples and samples of seawater in order to determine what kinds of DNA are just naturally present in the underwater deposition environment. And finally, we did DNA analysis of cargo items themselves, like this beautiful resin from the Uluburun shipwreck. We ground it up and we extracted it, and we got genuinely ancient DNA from inside this resin that sank on a shipwreck around 1,350 BC, making it over 3,300 years old.
So you can really get DNA from that old a site?
Yes, ancient DNA survives really well in the underwater deposition environment for a number of reasons. Number one, it's protected underwater from UV light, and UV light tends to damage DNA. The other thing that keeps it really well intact is that DNA loves to be kept cold. If you keep DNA in a refrigerator or a freezer, it's much more likely to survive for a long time. And the underwater deposition environment has a very cold and consistent temperature for the most part. Now, the tricky thing about DNA from underwater archaeological sites is that there's tons and tons of DNA just naturally present underwater. So if you take a little sample of seawater, you're just gonna get lots of DNA from modern things. Modern plants, modern animals, and even DNA from people is present naturally in seawater.